Example 6. Sketch a graph of f of x equals 3 sine of quantity 2, quantity x minus pi over 4 plus 1. Let's see if we can graph this based on what we know about sine of x and what we also know about functions and transformations. So let's observe the equation real quickly. So notice that this plus 1 is a vertical shift. A vertical shift up by 1. The function is shifted up by 1. We can see right here, x minus pi over 4, this is a shift, this is a horizontal shift, and it's a right by pi over 4. Adding into this, we've got a horizontal compression. A horizontal compression by a factor of 2. Okay. I want to make note of all these things as we go. And then we have a vertical stretch, or a horizontal stretch, pardon me. By 3. So based on what we know about sinusoidal functions, this is going to have an amplitude of 3. Sine of x, just go ahead and sketch that over here. At least one period of it. It goes 0. And then at pi over 2, and it repeats for 2 pi, that is its period. And it goes up to 1 and down to minus 1. So we have, it's 1 at pi over 2, it's 0 at pi, it's negative 1, 3 pi over 2, and back to 0 there. And it repeats. Okay, it continues in both directions. We call it a periodic function for a reason. All right, now we see that this has, just plain old sine of x, has an amplitude of 1. From its starting position, it goes up 1 and it goes down 1, up 1 and down 1. Because ours is stretched by a factor of 3, it's going to have a range of negative 3 to positive 3 if it weren't shifted as well. Okay, it's shifted up by 1. So we know up 1 and right pi over 4. Right, and pi over 4 is here, and let's just say this is 1, 2, 3, 4. Assume it's going by 1s. All right. If it goes up 1 and to the right pi over 4, we should have a point right here. Right, that's just taking into account the shifting. We're taking 1 point and just shifting it around, so we don't have to worry about the stretches in that case. So that's always a good move. Now we know that this had a period of 2 pi, okay, from 0 to 2 pi. Well, because it is horizontally compressed, that is now pi, so it repeats every pi. All right, so that means that if we go over, let's see, 1, 2, 3. We know it's going to be right here as well, and right here. Okay. Now we can deal with our amplitude. Okay, so we just took care of the horizontal compression. We've already taken care of shifting up and up into the right. Now the horizontal I think I was right the first time. All right, the vertical stretch by 3, so it's going to reach a peak of 3 above 1, so it's going to go up to 4. And it's going to happen halfway in between these points, so at pi over 2. And it'll go 3 below at pi, 1, 2, 3, pi and negative 2. And then since it's periodic, we have everything we need to know. All right, so it should be down here at minus 2. It should be, let's see, up, down, up, so at 3 pi over 2, should be 0 right there, and at 2 pi, we should be back at negative 2. Now just to connect the dots, and I'm going to add this end to indicate it continues going in that fashion. And there's our graph.